Thanks for coming, everybody. And I would love to have some other people giving talks, so definitely let us know if you've got an idea. Even if it's a short one, we can probably make it work. We can always put two together or something like that, so we can be flexible. So my name's Carl. I help run the meetup here with Nick, and I've been coming for many years. I'm the CTO at a little company called the Grade Network, along with Holly. Say hi, Holly. We grade papers for K through 12 teachers. I'm happy to talk ed tech, but won't do it up here about this. And then a couple of years ago, I got really into Docker, and so I wrote this short book. It's free at shipphp.com, and it's about how to build your first Docker application with PHP. And so it's like for people who are mid-level PHP developers and up who are just getting started in Docker, which I'm guessing is maybe roughly where this room is like mid to junior level PHP people, but you know, Docker's all new. So hopefully that's right up your alley. It's a lot of what I'll talk about today. And these slides I gave at Midwest PHP, so the URL is related to that. Okay, so what we're gonna cover is first a short introduction to just what containers are. So I'm gonna try to keep that pretty high level. And then we're gonna get into some more tactical, like actually how to run a PHP script, how to run an actual PHP website in Docker, what those commands look like, some of the considerations that you're gonna wanna think about if you're gonna use Docker, because it is a little different from other alternatives, and we'll get into those as well. And then finally, I'll cover a tiny bit about hosting in Docker. I'm mostly just gonna kind of give you like a, here are some options, now go do your research based on what you need. So that's gonna be, you know, we can talk more about that offline, but mostly this is focused on the actual nitty-gritty of using Docker. Okay. All right, so first of all, how many of you are using Docker to some extent? Okay, awesome, that's perfect. So we have at least some understanding out there. Is anybody using them in production regularly? Nobody's using container, oh, yes, excellent. So there's one brave soul back there using containers in production. So for the first couple of years that Docker came out, people were like, don't use containers in production. They're going to fall over and tear your whole site down with them. I don't think that's true anymore, but I do think you need to think about what you do in production. Like any production deployment, it's a big deal. And so people have been a little slower to pick them up in production than they have on the local dev side. So the most common way to maybe explain containers is to compare them or contrast them with virtual machines. How many of you have used virtual machines to some extent? They're very common in PHP. So I'm not surprised. In a virtual machine, what we would typically do if I want to define a virtual machine is I would go, you know, set up a virtual machine that's got Linux on it, let's say, and then I install PHP, Nginx, MySQL, whatever other services I need, and then they all run at the same time. It's all in one virtual machine. You kind of get this like all on or all off with a virtual machine, which has some, I mean, it's great. The downside is you kind of have to allocate, it's a big block of memory for a virtual machine. So running 4 of those on your computer may or may not be a good idea, depending on what you're running. And so Docker comes in and takes a little bit of a different approach. Instead of making it, you've got to turn everything on all at once, they've all got to be living in the same virtual machine, Docker lets you turn on individual containers that take care of one process each, and then network them together within an isolated environment. It's like in practice is something like this. Each of these Linux containers, and I'll get into the difference between Docker and Linux containers because they're really the same thing. Each of these Linux containers is one single process that's running. So we might have 3 PHP processes running, 1 MySQL, 1 Nginx, whatever. You can do any combination of things. So this provides some big advantages when it comes to, we'll look at in a second, scaling this, when it comes to sort of granular control over what services you're using, or spinning things up and down really quickly. So another thing that I wanted to point out, because Larry gave a really good, oh, actually this isn't, whoops. Was anybody here for Larry Garfield's talk on the container is a lie, I think is what it was called? I think a couple of us were. So he went into the whole difference between Docker containers and Linux containers. And they're basically, Docker is just building off of Linux containers. So was anybody familiar with Linux containers before? That was something I didn't know till Docker came around. And I think that's what a lot of developers just assume, that Docker invented containers because that was the first time we heard of them. But in reality, Linux containers have been a way of isolating the environment since the Linux kernel came out, I think, like the 70s and 80s. So like they've been around a long time. Docker's just done a really good job marketing them. but we'll get into that in a second. So again, containers are individual processes, so you can run many of them usually to run a single real web app. The big difference in why you can run just Docker containers as single processes is they don't have to each Docker container doesn't have to spin up its own guest operating system like a virtual machine does. So that's like where the bulk of a virtual machine's RAM and resources go, is just keeping the operating system running and all the sort of prerequisite programs. So what Docker does instead is takes the approach of, let's just have one sort of machine that has the basic operating system and kernel and all that, and then we'll just have the bin and libs, which is just like the individual processes, necessary components, installed in each container. So they share a lot more, in short. The reason that these things Docker containers have gotten really popular, there's several. Some of the biggest ones that have been compelling to me just in practice are the ability to start and stop containers granularly. So there's a couple times when this comes up. Let's say that I'm pushing something out to production and I'm starting to get heavy load on my server. I've got another server over here and they're maybe networked together already. I just need more PHP processes running. Well, with Docker, you can just say, spin up a new container and network it into everything else, and it's like you've got more processing power essentially ready. You can also do really cool things like, let's say at nighttime, our PHP processes get really like we're not using a lot of web traffic, we're doing a lot of background tasks, which is pretty common. We can sort of use Docker to granularly change how we're allocating different resources to let that happen. So that kind of stuff's really handy. And in addition, you can do things like adding a new service. So recently, in the last couple of years, I've been using Redis more for kind of queue storage and caching storage. And normally, if you were going to run a virtual machine, you needed to have Redis. You'd sort of pull the virtual machine down, you'd figure out, where's a new image that's got Redis, or you install Redis on that virtual machine, you save the image again. With Docker, you can literally just say, Docker run Redis, and then put it in your network, and boom, there you go, you've got Redis connected to your PHP containers. So it's really simple to get a new service and try it out for a little while, and not have to worry about, am I screwing up my base image that I use everywhere? I keep doing this the wrong way, sorry. And then the other thing that I found really handy about this, anybody using MySQL 8 yet? Yeah, nobody's going to upgrade their database. It's going to take years. Yeah, me neither, but I tried it out on a side project because I'm using Docker, and I was like, well, I've got, normally I'm using the MySQL 5.7 image, and then if I want to try MySQL 8 with a new app or with my existing app, all I have to do is tell Docker, this time run MySQL 8. I can actually load my exact same data from my existing app right into that container and try it out and see what happens. Make a copy first. Don't do it in production live. Try it in dev, try it local. Databases are always tricky. And there's a lot of people that think or sort of make the assertion that you probably shouldn't use containers for your database, or that should be the last place you use containers, which I think is fair. That's always like I prefer managed databases personally, where I'm not a DBA and people out there are better at it, so I'll pay them. But Docker can certainly be used to host a database, and we'll talk about some ways you can keep your data, make sure it doesn't go away with that container. The other thing I really love about Docker is the ability to track configuration and make sure that everybody on your team is using the exact same instance of every service you need. So this one is huge when you've worked, who's sort of started a new job in the last year, let's say? Anybody? How long did it take you to get an environment set up, your first day? Did it take 2 days, 1 day, half day?
2 days, but for me
2 days.
To get everything 100%, still not.
Still not there, yeah. Nick, how about you? You've been doing this a while. What do you?
Yeah, it didn't take long.
Didn't take long, okay, good. So for some people, this is fast. Were you using Docker or no? Okay, so Nick's just smart.
I do it a lot.
Yeah, Nick knows his stuff. I'm not surprised. So anyway, Docker can be helpful for this. Again, if you are somebody who's set up a PHP environment 30 million times, then maybe it's not a big deal. What I found really helpful, though, you can check your Docker compose file. We'll get into what that is in a second. Docker compose file into your version control, and then anytime anybody pulls down that repository, they just say Docker compose up, and boom, the whole thing's running. So they've got the exact same version of PHP that you're running, assuming you're running that in production, and same version of the database, and same version of any other services. So that part is really, really powerful for getting people started. Holly, what did it take once we got things cleaned up?
Like afternoon.
An afternoon. So we're getting better. Yeah. We're still plenty of room for improvement. Another reason I like Docker is the continuous integration speed, or the speed at which you can get containers started and stopped. And this is really good for continuous integration. So I said that backwards. But basically with a Docker container, because you're not starting the whole operating system, there's not a 30-second to 2-minute boot time. There's like 2 or 3 second boot time for a container. So that's a huge improvement when you're running a continuous integration environment where you want to run your tests automatically between pushing it out to production. And so Docker is super helpful for that. And I think this is an area where a lot of companies see big advantages in using Docker because they can sort of spin up a bunch of containers, run their tests, tear it all down, and it takes very little resources to do that, and it's very fast. It's also a lot easier and faster to scale based on need if you're maintaining your own infrastructure rather than trying to set up your own virtual servers every time you need to, say, add more capacity. The downside, like anything new, there's a learning curve. So the reason I'm guessing a lot of you are here is because there's a learning curve and you're like, I wouldn't mind seeing how somebody else does it first. So hopefully this talk will help with that, but there definitely is. You have to if you're, I guess, is anybody using Bash regularly? I'm assuming most people. Yeah, PHP or something. So if you're using Bash regularly, you're going to use those commands, but then you're also going to do the Docker stuff with it. So it's like going to add an extra layer on there. And then security and isolation is a whole nother topic that I'm not going to really get into in depth because it's beyond the scope of sort of entry-level local development in Docker. But when you get to shipping your containers in production, you need to think about what user is running these containers, how much permission do they have, how much do I want my different containers to be networked together so that they can share information or not. So a lot to think about there. All right. Now, all this stuff I've set up to now applies to Linux containers in general, but it also does apply to Docker containers specifically. So why do we care so much about Docker? Why is Docker the container engine we're talking about instead of LXC, which is Linux containers, or one of the 2 or 3 other major players in Linux container space? So the big reasons I see Docker getting so much attention, I mean, it's open source, which is great. We love open source tools. That means it's free in general. They do have enterprise offerings now. I think that sort of tends to cater to larger companies, so I haven't worked with it, but it's out there and people obviously use it. They're a huge company. They're talking about going public. They've raised over $300 million. So they've got a lot of money to spend on marketing, and I think that's been a lot of the reason for their success. Docker has kind of tied itself to the idea of DevOps. And so one thing I'll just sort of dispel here is like Docker's cool, it's useful, but it isn't DevOps in itself. It is not the only way to deploy things in an agile manner. It's not the only way to deal with the problems of isolated environments and spinning up different tools quickly. So it's one tool and it's great, but don't praise it too much. It's got a lot of downsides. Also, I guess this is just kind of to give you an idea of how popular it's gotten. So this stopped in, I think, middle of 2018 is when the last of this is. But we had over 25% of companies adopting Docker in some real world environment for them. So it's gotten really popular. And the other thing that's interesting about Docker to me, and I go to a lot of conferences, I talk to a lot of people who are working at much larger companies than me, and big companies love Docker because what it allows their devs to do is essentially get around the whole server management department that used to have to install things for them. So not long ago in enterprise IT, and I think this is probably still true in a lot of enterprise IT, if you were a dev and you said, hey, I want to try using Redis, you'd have to go to a sysadmin and you'd say, hey, I'd like a server with Redis. And he'd say, it'll be 6 weeks because we've got a backlog of servers to set up and you're not that important right now. And then you finally get one and it's like 2 versions behind, you ask for a patch and now it's another 6 weeks on there. So this process is kind of crazy, but it's the way that a lot of companies work because of security concerns and other things. So Docker kind of like lets them get around. They say, I want a virtual environment with Docker on it. You basically got the ability to get almost anything. So I think that's part of the reason from talking to people that this has gotten so popular is the ability to try new tools faster. All right, any questions so far on the high level? What is Docker? Everybody with me so far? We all in agreement? We know what's going on? Or don't want to admit it, but that's okay. We'll look at this. So I'm a very hands-on learner. I'm not the kind of person who's going to like read a book and really absorb that much. I like to get in there and write some code. So I'm going to do a little of just showing what Docker code looks like, or running a PHP code in Docker looks like. So the very first thing we're going to do is run a built-in PHP command. So anybody from the command line, if you do php-v, you should see some version of PHP pop up. This is just built into PHP. You probably don't use it much because it's not that useful in day-to-day work, but every now and then you get a new computer, you want to see what's running. So this is how you'd run that same command in Docker. You say docker run, which tells Docker, hey, I'm going to be spinning up and starting a new container. We'll get into just a second what containers and images are and the difference, but for now we just know that this is sort of the kickoff command for a Docker command. And then PHP 7.3 is saying to Docker, base whatever you're doing here on the image called PHP 7.3. And all these images, Docker images, are available on Docker Hub for the most part. Most open source projects have a ton of versions. So for example, PHP might have at least versions 7.0 up through 7.3, and maybe so occasionally they even have like a 7.4 alpha or beta that you can go to either officially or unofficially. So this will let you pick what version of PHP you want to run. And then finally, php-v, which is the command we actually wanted to run in the first place. So like I said, a little more verbose, a little more like you got to type a little more, or you get, write yourself some wrapper commands or something clever like that. But when this comes down to it, what you can do is, let's say I want to try running something in PHP 7.2, or I want to try it in 5.6. You can find a Docker image for it and specify that, and it'll come up here. So that's some of the power of it. You're not having to download a new version of PHP and install it on your system and figure out how to network it together. Next, let's look at running a PHP file. So this is, let's assume I've got a little hello world file that just echoes hello world. So something that, I'm not going to show PHP code because you can go find an example, or I'm happy to actually, in the book, if you want to download that, it's got more code that goes in depth with the PHP. But basically what we're going to do is that same Docker run command, and then we're going to add -v. Now I'm going to get to volumes here in just a second, but basically what this is saying to Docker is, get me the files in this directory that I'm giving you before the colon, and put them in the directory after the colon in the container that you run. So this is going to be a little confusing, and I've got a slide on this next. Yeah. So the way that Docker achieves some amount of isolation within each container is it doesn't give the container access to the underlying file system. What that means is when you're in a Docker container, you don't get to go reach down and grab things out of the host machine. And that's good, because if they could do that, they would be able to have access to basically anything on your host machine, which in any kind of real environment is not a good idea. So Docker sets up this virtual environment that gives the Docker container access to a little slice of your file system. And then when you mount a volume, what you're saying to Docker is, I also want you to have access to this little slice of the file system, or rather it's keep this slice of the file system in sync with what that slice of the file system in the container. So this allows you to have, this kind of volume is called a bind mount, because it's allowing you to have a two-way binding between your host file system and the Docker container that's running. So when you're doing local development, a bind mount is the easiest way to make sure you update your code on the host machine, just like you would if you were running PHP natively, and then all of a sudden it's magically updated in the container. That's sort of the quick and dirty way to do that. And then the last bit of that command, we kind of we'll back up and just make sure we cover that. The last bit is just running the hello world app we had. So it's PHP app hello world. And that's going to echo it. Does that make sense with volumes? This is kind of one of those tricky topics that took me a couple read-throughs to wrap my head around at first. But a similar, this similar paradigm exists in virtual environments too, so it's not completely new to Docker.
So when you're running your Docker application, you have Bash running in the background?
Well, I guess I have my host machine. I may have a terminal shell open, and then I may have the Docker container over here, and it's doing its thing. We'll get into this too in a second, but you can also do it's sort of an SSH into the container. It feels like that. It's not quite that, but for practical purposes, there's a way to get into that container and run new bash commands or shell commands or whatever. So that's possible too. Yeah.
Are the volumes, are they faster or slower than, say, virtual machines?
Yeah, so there's a couple kinds of volumes that Docker runs. I definitely don't know which ones are faster compared to virtual machines. I I couldn't go that deep into it, but Docker has a bind mount, which is where you're basically saying these two slices of file system are, let's keep them in sync. And then they'll have, what are they called? They have a temporary file system mount, which is for things like environmental variables, although it's not the best way to get environmental variables in, but that's what people use it for, like secret config files and things. It's like, basically it uploads it in the container once, and the container stops, it removes those files. And then there's a named volume, which basically is like, it's a one-way volume where we take files from the file system, put them in the container, and then they run in the container, but they don't get synced back to the host file system. And there's like, those are faster than having the two-way binding, because two-way binding is going to be, I mean, you're changing the host file system, so things get slower. But I don't know, I don't have any benchmark data. Yeah. It's gotten a lot better though. One thing about Docker is like, it's still pretty new. So the first couple of years, things were it was very bad. I mean, there were some things that were really slow, that were annoying to deal with. For a while, the workaround for slow volume, like bind mounts, was they had this smart cache that you could try to apply to it. And it sometimes worked well, and sometimes you'd be like changing the file, and it's not changing, and cache is, right. Anybody, if you've worked with cache, it's dangerous. So let's build an actual web application. And this is going to be a little more complicated than a single PHP container, because I think that's where it gets interesting. But let's first talk about how containers are made. So I've been throwing around a lot of terminology, and these three words, at least image and container, have come up. Is anybody familiar with a Docker file? Okay, a few of you, worked with Docker a little more. So a Docker file is basically it's kind of like the recipe for creating a Docker image. And then the Docker image is a template that's all ready to go that you start a container from. And it's kind of weird that there's these three different artifacts, but the way it works is that Docker file will live in my project. And it'll be like, copy my code into the Docker image that you're building, and then run some scripts on it, and then make sure you do the npm install and the npm whatever else. And then ultimately it's going to have a final run command, and when you say Docker run, it's going to take that image and run it as a running container. And that container is, again, a single process that can be stopped at any time, and it's sort of like short-lived kind of thing. Does that kind of make sense? We'll get into looking at an example of creating one, but this is another one of those topics in Docker that took me a couple go-arounds to fully get my head around. Yeah. Okay. So let's build our own custom PHP image. That's kind of the next step here. A little bit of weirdness about PHP. It's a great language, but also it's got its quirks, right? So PHP, unlike a lot of server-side languages, comes bundled with, it basically works really closely with Apache. And so there's a whole sort of build of PHP that runs with Apache. Is that the right way to say that? More or less? Yeah, okay. And they've done the same thing in their Docker images. So there's a PHP:/Apache Docker image, which basically says, get me PHP and Apache together as one. Normally in Docker, this is not best practice. Normally we want to have a Docker image for PHP, a Docker image for Apache, and then we network them together. But because PHP has decided to do it this way, and it's much simpler, I'll kind of show you how this way would work. You can also run your PHP image with PHP FPM and then Nginx, and you can have two separate images or containers running and network together. If none of that makes sense to you, don't worry about it too much. Go with the PHP Apache image. It's going to be a lot faster to get you started. And it's just kind of the default simple way to do PHP. And then the next thing we do is install any extensions we need. So this is a Docker file. This is going to live at the root of my project. And when I say install extensions, by default, the Docker image that PHP has provided doesn't have extensions like MySQL or any of the image manipulation extensions you can get or other cool stuff that you can sort of build with PHP. And the reason for that is Docker images, they try to keep them relatively lean because it's an all-purpose sort of tool. So this could be used for lots of different apps, and I may not want all that extra gunk in there. And so what PHP is letting us do is decide which extensions we want to install. So in my case here, I'm just extracting the source, which is just kind of like getting me ready to install, and then I'm installing MySQLi, which will let me connect to a MySQL container. And then the last step here is we're just going to copy the code from our current directory, which is to var www HTML, which is where Apache will serve the files out of by default. So if this were living in the root of a PHP project, you would basically just say, let's see, it should be the next thing, yeah, docker build. I can tag it, which is -t, with any name I want. That name is arbitrary. When it's on your local machine, doesn't matter. If you're going to push it up to a container registry, we'll get into that in a second, but you could name it something nicer. For now, we're just going to call this php-docker. And then that little // is the path to the Docker file I'm building. So usually it's going to be dot or //, whatever you want to do. Yeah. And this is going to build you an image. So going back to, I think, going back to this, what we're doing is we started with a Docker file. We've now built a Docker image, and next thing we're going to do is run a Docker container. Uh-oh. Okay. Make sure I didn't skip anything there. Cool, so this is the last step for just running a PHP container. Now, we'll get into a second the other containers we're going to run as well. So we're going to run MySQL to make sure we've got a database. But for now, we'll just test this out, make sure it works. And we say docker run. And then the one thing new here that I'm going to introduce is -p 8000:80. So with a lot of Docker commands, you're doing this like something : something else. And basically what you're saying is, on my host machine, : on the Docker machine. And so that means on the Docker containers port 80, I want to run my host machine's port 8000. And it maps them together so that whatever's running on that container's port 80 is running now on my local host 8000. And we should be good. We've got a local host 8000. Yeah. That was me in 4th grade. Yeah, no. Okay, so again, we're just still running a PHP container. We did build our own custom PHP image for this one, so it's a little more advanced. But we haven't really gotten into now networking containers together, which is an important part of Docker. And this is where I do think, admittedly, it's a little harder maybe than working with a virtual machine. Because in a virtual machine, I've got all my processes installed on the same exact machine, and so they all are, by default kind of networked together. There's not a lot of questions of can PHP talk to MySQL. They kind of just work together well. And this is what we would do on a typical virtual machine or if I'm installing MySQL locally. But if we want to go with Docker, what we're going to do is we're going to take the 2 Docker images that we want to run. So in our case, it's the PHP Docker one we just built, and then the MySQL one that whatever we get from Docker Hub. And we're going to say Docker run, and we're also going to add in this little thing about linking those containers together. So we'll look at what that looks like. But another thing I'll kind of like jump over to an aside, because before I like to run a database container, I want to tell you, okay, what happens to your data when you're running this ephemeral container that starts and stops and has nothing left when you're done with it. This is where you need to use volumes wisely, because that'll save your data, hopefully. So obviously you're going to do this locally a few times before you sort of get the courage to run it in production. So what you want to do is mount a volume with the path to your data from the container into, from your host machine into the container. And do that 2-way bind mount is usually the easiest way to do this, but you can do it other ways as well. We'll look at what that looks like in practice here in a second. Okay, this one's long. So again, running Docker commands, it's like you just add more and more stuff to your command line, and you have to get real comfortable writing long commands. What I've done in the past is what I do currently is wrap a lot of these long Docker run commands in NPM scripts or composer scripts, which can sort of save you some trouble. There's also some tools Docker gives us, and I'll get into those in a second. But sort of simple, quick, and dirty way to do it. So the first thing we're doing here is we're mapping port 33060 on the local host to 3306 on the container. Now the reason I might do that is that by default, a lot of systems have MySQL already installed, and so I may not want to use that version. I want to use the containers version. So I'm going to use a different port than my local MySQL is running on. And then the next flag we have set here is -E. So this is a whole other topic in itself, but you've got to get environmental variables into these running containers somehow. You've got to get secret stuff in there. And that's where -E comes in. Now in this case, the only environmental variable I added was to allow empty root password. So don't do that anywhere besides local machine when you're just playing around. But this lets you essentially get started without having to even authenticate MySQL, which again, not good in any practice other than local development. But for now. And then the next two are we want to mount this volume of our database's data into the path where MySQL actually stores data. Is anybody really into databases by chance? I'm not. You like databases? Okay. So one thing that blew my mind as I got into Docker, and maybe this is simple, maybe I'm stupid for like thinking this is cool, is that ultimately databases just save things on the file system. There's nothing magical about them. There are files you can open up and see the data, although you can't tell what it is because it's all encoded and it's like, you know, all that. But essentially, all the data lives on a file system. It's not magic. It's not like in RAM all the time. It's right. It's like, duh. Like, I don't know why that was so amazing to me. So all you do if you want to make sure that data stays around is you mount the data from your file system into the container and vice versa. You do the two-way bind mount. And now when that container shuts down, at least I've got all the data files saved. So didn't lose anything. Now, I think that's a little different for for Mongo, which only syncs maybe every minute or something like that. So you do have a possibility of losing data, but we're in PHP, we don't use Mongo, so whatever. That's for those node people. The next thing we're going to do here is name this container. So this is an option that you can add in if you want to make it easier to link containers together. You can name them so that you can then reference them by that name. So this is optional, but it's nice to do. I wouldn't probably pick a name this short other than I was trying to save space because DB is pretty obscure, but maybe MySQL 5.7 is a name or something like that. Okay. And then this is how we run that same PHP container we just ran, but with a link to the MySQL container that just started. And so it's just -- link DB. And that connects the two containers, and now PHP can talk to MySQL. And so hopefully at this point, the whole thing is working with data. Yeah. Okay.
Can you go back one time?
Yeah, let's see if I can figure this thing out. Yeah. Okay, I got it.
So they talk over which port? This was for the...
They talk over which port is the question, which is a great question. So they are going to, by default, talk over the ports that, like MySQL, the image has a port that's open by default to any other containers. So your PHP has to know to go to 3306 to get there, yeah. Now you could change that, and you can make an image that goes to whatever port you want, or change the MySQL config so that it opens up whatever port. But yeah.
So this is telling the PHP one to talk to the database one over 33.
Yeah, 3306 is the default, so we're just not changing the default essentially. Yeah. Now there's some cool stuff happening. We'll get into, so in a minute we'll get into how you actually make the reference. There's Docker sets up DNS records for all your running containers and allows you to reference them by the names you gave them. So earlier when I named that container DB, anywhere in my PHP code, like in the environmental file, instead of saying the IP address of my database or whatever, I just say DB : 3306, and that'll connect me over to MySQL. So that's kind of nifty. Also kind of dangerous if you don't know that. So know what your names for your containers are. Okay, there's a bunch of stuff that I didn't really work into those examples that I want to just sort of touch on because they're super common problems in PHP that we need to solve with Docker. The first is .env files. Does anybody use .env files? I'm a big fan of this because if I forget to run scripts with all the -e flags in there all the time, and that's just a pain to keep up with. So for local development, I think .env files are awesome. Production, there's a whole nother debate, and that's a different story, so it depends on your situation. But a .env file is essentially one big file that's got all your environmental variables in it. So it makes it really easy to add all those environmental variables to your Docker container by just saying --env file equals, and then the path to the environmental file you want to use.
Do you edit that though? You would you edit that it was let's say Laravel?
Yeah, so Laravel comes with a default .env file usually, and a lot of times in local I may not have to do a lot of editing of that. It may be pretty much good enough set up, but in production I definitely will have different secrets and passwords and all that stuff. Yeah. All right, and then going the wrong way. So image registries are another thing I've talked about a couple times but haven't really spent the time they're worth. So GitHub is a place for hosting your code repositories. Docker has this thing called Docker Hub, which is for hosting your Docker images. And it's free for open source images, so this is a good place to start. Almost every major open source or big project has a Docker Hub page. So if you search Docker PHP, you're going to get the official Docker Hub page for PHP. If you search Docker MySQL, you get the same thing. And this is basically where you'll find all the different versions of PHP that are still supported and have Docker images, as well as special instructions about how to run them, all the extensions you can install. So get real familiar with these pages. But this is also where you can push your code up to and then have other people pull it down and run it and have it run the exact same code you're running. So part of the power of Docker is being able to share code and know that it's the exact same thing. And a registry is where you store that up in the cloud. You can host your own registry that's private. You can get private Docker registries through Docker Hub. That, I think, costs you, however many dollars a month they charge. That's part of how they make money. And then all the big hosting providers now offer some registry. Some other commands that are super handy, so you can list all the running containers, and this is Docker PS. That's just going to show you the names of them, what ports they're using, and then if you want to stop them, you say Docker stop, and then the name or container ID of that running container. You can inspect a running container, which lets you see the environmental variables, any of the flags that were run at start time, anything else about that container. So this is another sort of gotcha about running Docker containers is if anyone has access to your host machine and has permission to run Docker, they can see everything that's running in those Docker containers. So if that means you have all your database secrets in that container and they say Docker, they get access, they say Docker inspect, they can see all that stuff. So you have to know that and just, like anything, don't let people get access to your production servers unless they need it, but be aware. And then I was talking a little bit earlier about this, but when you need to essentially SSH into a container, there's this command called docker exec. Now what this actually does, I put SSH in quotes because that's not really what it's doing. What it actually does is spins up an exact replica container of at that time, and then lets you run any terminal command you want from it. So if you want to run bash, you can run bash. If you want to run some other command, so you can do say you have a running PHP container, and then you want to say docker exec composer install or composer update or something on that, you could do that. And then you can tail the logs. So honestly, I had very rarely used PHP's logs because they're such a pain to get to and find and all that. And Docker makes this super easy, which I like. It's just remembering where PHP is storing its logs is always a pain to me. So it's always the same. What's cool about this is that all these big Docker projects, they basically pipe their logs through Docker's log system so that they all go out to the same place. And then if you want to build a log aggregator, you just have a script that runs Docker logs on all your containers and you can see everything all at once. So super handy for that. Okay, so up to this point, we built a custom Docker image for our PHP app. We ran a container with MySQL. We linked those together. I mean, we've got the basics of running a real web application, at least the start of it. But this was done the hard way, and I did it the hard way on purpose just to show you. The easy way is Docker Compose. So what Docker Compose does is it basically lets you write a single YAML file that has everything you need to know about the Docker containers that you want to run for an application in one place, and you can check it into version control. So this is where instead of running those 2 or 3 complicated Docker run commands that I was running before, I just say Docker Compose up, and assuming my YAML file was written correctly, it's going to spin up however many containers I had in that specified. So in real life, this is what you do. I only explain the other parts just so you kind of have a foundational knowledge of what a container is, how you run it. This is really where you're going to get a lot of power out of Docker. So this is what a Docker Compose file looks like in practice. This is doing roughly the same thing. Maybe a couple things I switched out here as our 2 containers was doing. We have 2 services, web and database. Web is a PHP Docker image on port 8000 mapped to port 80. And then database, I'm using MariaDB this time instead of MySQL, but they're analogous in this case. And then I'm mounting the data from a volume that's specified at the bottom. So now instead of doing all these different Docker run commands with a ton of flags, I'm just saying Docker Compose up. Very simple. Okay, yes, sir.
So we had to manually link the PHP to MySQL before.
Yeah.
In that, there was no link candidates.
Yeah. Yeah, so Docker changed this somewhat recently. So if you look up old tutorials, you may see like a Docker Compose with a link or relies on flag. But now by default, a Docker Compose file, all the services in it are going to be in the same network. So that means that Docker will let them talk to each other. You can actually turn that off as well. So that may not be a good thing for every application. So you can also tell Docker in your Docker Compose file, these services are in this network and these services are in this network and they shouldn't talk to each other. So you could have it either way. Yeah. But I think they figured that most people are linking them. That's why they're in the same file usually. Any other questions on Compose? Cool. Okay. So obviously this is a lot of pros to this. I've already kind of talked about it. It's a lot easier to use day to day. The downside to this is you've got an abstraction layer now between you and Docker. And so the reason I always sort of go through what Docker is on its own is that this abstraction layer makes it a little harder to debug things, makes it a little harder to know what exactly is running. If you wanted to stop and start one of those containers individually, you can do that, but you probably have to use a Docker start and stop or run command instead of going through Docker Compose. And so it's good to know. The options are also not the same. So for some reason, the names are different in some things. So you have to watch that. You have to go check the docs, and it's annoying. But Docker, like PHP, has been cobbled together over lots of different needs over a few years now. So it's not all perfectly designed. And it's got its own weird versioning system that I still don't fully understand. So does anybody understand Docker Compose's versioning system? It's like version 3 is Swarm and version 2 is... Yeah, okay. So nobody knows. I wish I could be more helpful. It's in the docs, but I never can make sense of it. So I try to use the latest version, but I'm not sure if that's even right. Okay, so that's Docker for local development in a nutshell. If that didn't make any sense to you or you'd love to walk through that slower, these slides are up, and I've got the link at the end. And the book I wrote a couple years ago also goes through this step-by-step with all the code samples. So like, hopefully you can get by on that. This part is new though, and this is something I didn't write about because the hosting options were drastically different 2 years ago than they are today. And this is maybe the more, challenging part of Docker now. So one thing we've touched on a couple times is volumes, and this is one of the bigger problems around, or questions maybe, around how you deal with persistence in Docker containers. And so one of the solutions is volumes, and usually that's the right way to go, but you have to decide like, where do I want to store those volumes? So if you think about it, and you're running like 5 servers that all have Docker containers running on them, and they all need access to one of the server's volume of data, how are you going to do that quickly? You start to put things over like a networked file system, and that gets really slow compared to like being on the actual hardware. I don't know the ins and outs of all network file systems and what makes them good or bad. So if you do want to get into that, that's a whole other topic you can do. But you have to think about that for production. You also have to think about how you're going to sort of start and stop these containers. And so let's say that you want to update your code. Do you want to pull the container down and stop it and then start it back up? Or do you want to have zero downtime where it's like you spin 2 containers up, your old code and new code, and then you flip a switch and they kind of like move over to the new one, and then you gracefully take the old one down, which sounds cool and sexy, but it's also like really hard, more work to do. And so there's some tools to help with that that I'll get into in a second. And then I always ask people, do you really need Docker in production? It totally depends on what you're doing. If you've got a great hosting solution that works on virtual machines, or it's on Heroku, or it's on whatever, like it may or may not be worth switching. Maybe you can try it out in dev or testing and see what that's like before you sort of go full on in it. I think where Docker is the most useful is when you've got a pretty good amount of scale, and then you also need to have variable workloads in those servers. So for example, what I was saying earlier about how, let's say during the day or sometimes of year, I need to devote all my PHP containers to web traffic. And then sometimes of year, I need to pull those back and just do background tasks or processing. That's a really great use case for Docker. It would save you a ton of money because you don't have to spin up or start and stop servers or change things manually. Docker will take care of a lot of that. Okay. So this is like the gamut of hosting options and the way that I think about them, from easiest to set up to most powerful and most maybe enterprise ready. So if you're just going to use Docker in a side project, and you want to try just seeing what it's like running something in a Docker container, you want a single container, you can use single container hosting. So there's all the big providers have some form of this. You can basically just point the provider to a Docker image. You say, hey, I want to run this Docker image, and you tell it maybe open these ports and here's some environmental variables, and they'll just run that one container. So in the case where we have our, it's almost like running a function, a serverless function. It's just like, run that container, and then maybe when the container stops, it's dead, or maybe keep it running and just make sure there's a port open or whatever. So Sloppy IO does this, Azure Container Instances do this, and this can be really good for you just got a quick workload, you want to spin up and stop, or you are doing a side project, you just want to try this out. The next level up is you take what we did with Docker Compose and just plop it on a server, and then make sure it's got some kind of process to keep it running. So you can run Docker Compose as a daemon, or have some process manager make sure it stays up or something like that, depending on what your uptime needs are. But this is good for like small to mid-sized projects maybe. And it's like, if you can run everything on one server, this might work. Or maybe your database is off on another server and this is just your app server, this could work. I think this is a good next step for people who are just getting good at getting used to Docker and want to learn how to run it in production and try it out. But it also is going to run into problems if you want to run it across multiple servers. Docker Compose is only built for one server. And so the next level up is Docker Swarm. So they built this tool that's like Compose, but lets you do it across multiple servers. And with that, what you're going to have is like a manager node, or several manager nodes probably. So you'll have 3 servers that keep your 5 production servers running, or something like that. So obviously the cost gets pretty high once you're doing this. You've got 8 servers running just to keep the thing going, but it's also got great uptime, and it's got the ability to do this like these cool, auto scaling, or even automatic deployments and rolling deployments, so you don't break things, cool stuff like that. But a lot more work to administer, a lot more work to get going. And then Kubernetes. So anybody heard of Kubernetes? This is the hot thing right now. So Docker was hot a couple years ago. Kubernetes is hot now. It's basically using containers, Docker containers or Linux containers, and it's taking care of all the orchestration problems. So that means all the things about getting those containers running on a server, making sure the servers stay together. It's basically doing a lot of what Docker Swarm does, but people have started to really like Kubernetes more. And so it's winning the race. Who knows where this will land in a year or two. But they solve a lot of the same problems. The weird thing to me about Kubernetes, and I started using it maybe almost a year ago now, and the weird thing is they have different names for everything. So now you have this whole new naming system to learn for your containers, which is not the end of the world, but it's annoying. And if you're just new to Docker, I don't encourage you to jump all the way to Kubernetes. Maybe take it slow here, take a couple baby steps. Maybe not, maybe you're really quick at these things. And if you're like good with managing servers, this stuff might come really naturally to you. But anyway, so Kubernetes is out there, very powerful, super cool. They're also, you can self-host it or get a managed instance of Kubernetes. And managed would mean like, you basically just tell the service provider, Azure or Amazon or whatever, Google, I guess is the obvious one. You tell them, here's all my, what do they call them, pods that I want to run, and here's all the special stuff you need to know about them, and then they just run them and keep them running. So, relatively easy. Awesome. Thank you all so much. That's my talk. You can get these slides at pcgo.co/mwphp and book at shipphp.com. And I'm going to hang around for a few minutes, although we have to leave at 8. So we have 20 minutes.
We have to be out of here by 8.
Be out by 8. So we'll be pushing you out the door like 5 till. But thank you all so much.